Hey course 3ers, this is part 2 of my 3-part series on irrational numbers, geometry, volume, etc. First of all, you've been down this road before. You'll recognize this right at the top. This is the Pythagorean theorem. And while we've never done a proof of it, you can sure bet your lucky stars you're going to do a proof of it when you get to high school geometry. One thing I just want to remind you of is the a squared, one side, plus the other side squared. So you can think of it base and height. Each of those squared individually added together is equal to the hypotenuse squared. Remember, C is always the hypotenuse, whether you are looking for the hypotenuse or you know the hypotenuse. So for example, in this problem here, I know one side of the triangle. I should put a little right symbol there. That's a right triangle. I know this side is 3. I know the hypotenuse is 5. And so what I need to do is figure out that side. So I've got 3 squared is 9 plus b squared equals 25. Again, using a little bit of algebra, I'm going to subtract 9 from both sides. I get b squared equals 16. Oh, how do you unsquare something? Of course, you square root it. So now, the power of changing colors, I square root both sides, and b is equal to 4. Nice. You can see how this ties into the previous lesson, right? You're now square rooting things. If you're working with volumes, you might be cube rooting. As you do other stuff, you might be going even crazier dimensions. Now take a look at the triangle in the bottom. It might not look like an equilateral triangle, but based on the numbers, that thing is an equilateral triangle. All 3 sides have a side length of 4. That makes it an equilateral triangle. But if I was going to try to find the area of that triangle, I would have to figure out the height. Aha! I can cut it perfectly in half, and the height is always perpendicular to the base. So basically what I'm saying is, oh, wait a minute, this little dotted line here is actually the height. All right? Just as a reminder, the area of a triangle equals 1/2 the base times the height. Lowercase b means the base of the side, one dimension. Capital B, as you're going to see later on, means the area of the base when we get into 3-dimensional figures. All right, well, let's see. I know the base is 4. So I've got area equals 1/2 times 4. Now what I need to do is figure out the height. Well, in order to do this, let's go and use the Pythagorean theorem to figure it out. So really what I've got here is a triangle that looks like this. This is 2 because I cut it in half. This is 4. All right, Pythagorean theorem again. So I've got 2 squared plus the height, I'll call it the height squared, equals 4 squared. All right, so that's 4 plus height squared equals 16. I subtract 4 from both sides, and I get height squared equals 12. And as you recall from the last lesson, I take the square roots of both sides. The height is the square root of 12. Now, you could go ahead and put that in on your calculator, right? And you'd get a number. I mean, if I go back to my previous slide here, I'd be like, oh, wait a minute, 12. It'd be like a number between 3 and 4. Right? So that's really what it is. But now I can actually plug that in to my formula. Okay, here's my height. And the square root of 12. Now, in this case, I need to use a calculator to figure this out. Half of 4 is 2, and then 2 times the square root of 12. And I will. I'm just going to do it on my calculator. 2 times second square root 12. I'll try to hold that up so you can see it. 2 times the square root of 12. And I hit enter, and I get 6.928. So I'm going to call that 6.93. 6.93. I don't have units here. We're going to go centimeters squared. So that is an application of using an irrational number in a real length. Now, where are we going to go from here? Oh boy. Now I'm going to introduce a 3-dimensional shape. Again, I'm going to try to keep this real brief. The idea here is I'm going to build a ramp out of plywood. And this sheet right here is a 4x8 sheet of plywood. I'm going to keep it 4 on this side. So again, the diagonal's 8, but how far does that have to be? Again, what I'm going to do is use my Pythagorean theorem. 8 squared. Notice in this case I put c first. C equals 4 squared plus question mark squared. So that's 64, 16. Subtract 16 from both. 64 minus 16 is 48. 48 equals question mark squared. Take the square root of both sides. And question mark equals the square root of 48. And again, when I put in the square root of 48 on my calculator, whoa, I just got the same number. Crazy. 2 problems in a row. So it's roughly, 6.928, blah, 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 blah. Again, if I want to find the area of that, well, okay, area of a triangle. Area of a triangle equals 1/2 base times height. Okay, 1/2. The base is now the square root of 48. The height is 4. So wait a minute. I already have the square root of 48 on my calculator. 4 times 1/2 is 2, so I could just multiply that by times 2. And again, that's 13.856, so 86. So the area of the side of this triangle, this one right there, is 13.86 square feet. In mathematics, whenever you take a radical number and you say, well, I got to write it down, the exact answer is truly the square root of 48, right? I mean, it's a number. And if you said, well, roughly that's 6.928, so we'll call it 6. Yeah, well, it's pretty close to 6.93. The problem with this is when you're doing big calculations and you take these numbers, and they're real numbers. The square root of 48 is a real number. But by converting it to a decimal, you lose value because you have to cut it off at some point. This is really important when you think about multiplying things by big numbers, astronomy, or really small numbers. When you're going down to cells or within cells, you're working with DNA. You don't want to start rounding things. You're going to miss. If you're aiming for the stars and you're a few decimal places off because you rounded it, multiply that by 1 trillion miles and you're going to be way the heck off. What mathematicians have done is they said, hey, let's simplify these radicals. All right, so let's take a base root, which is 2 prime numbers multiplied together, and kind of like factor everything out and then simplify it. I'm just going to give you a short example. The square root of 48 is really 2 numbers multiplied together. It's the square root of 16 and the square root of 3. Anytime you can break a radical into like a perfect square, you're going to make your life easier. I could always divide it by 2 and then have like 2 times 24, but I'm just going to go right ahead here. The square root of 16 is just 4. So this is just 4. I can't simplify the square root of 3 anymore. So this is what you're called. These two things are the same thing. They're truly the same thing. But this is called a simplified radical. You will see this much further on in your career. I just wanted to kind of introduce it to you now because that's going to be another step down the road. The last thing I want to show you is how does this look in 3 dimensions? Well, if you had a 3-dimensional figure and you said, well, how long is the diagonal from one corner to the next? Well, let's just do it. You say, well, wait a minute. Really what I'm saying is I need to draw like a right triangle like that, and oh, wait a minute, this is, if I figured out this diagonal in here, that's also a right angle, you'd be like, oh wait, okay, I can figure that one out. So that would be 6 squared plus 3 squared equals, that the c squared one. And again, what I'm doing is this one right in there. So that would be 36 plus 9 c squared, 45 equals c squared. C equals the square root of 45. Sweet, I figured that out. Now, I know the height is 4. I can do it again to figure out the diagonal. So now the purple diagonal, I'll use the purple diagonal, is going to be the square root of 45 squared plus 4 squared, and that's going to be that c squared, the one I'm really looking for, the big long diagonal in between the thing. As a quick reminder, the square root of anything times itself is the radicand. So the square root of 45 times the square root of 45 is 45. 4 squared is 16. That's c squared. 45 and 16 is 61. C squared. So that means I'm out of space here. C equals the square root of 61. Awesome. Just so you know, there's a little shortcut, and I want you to remember this. It's like the Pythagorean theorem, it's just in 3D. If you want to find a diagonal corner to corner, the formula is a squared plus b squared plus c squared equals d squared. And I'll show you, we're still going to get the square root of 61. Let's plug it in. I've got side lengths of 4, 3, and 6. 16 plus 9 plus 36 is, guess what? 61. And if you don't believe me, prove me wrong. That is a really important trick that we would spend much more time on in real life. I'm sorry to make this a 12-minute video. I wish I could make it shorter. I hope you learned a lot in this video, especially this last little trick. You're going to see this a lot. This stumps a lot of students, but really, when you think add another dimension, just add another letter.